My name is Jim Orbiana. I'll be the first half of your presentation today. I'll be going over the materials that we typically reuse during the remanufacturing of transformers. My co-presenter will be Kyle Wattenbergen, and he'll go over the oil reclamation in biotemp fluid. So when we talk about transformers, there's several parts of the transformers that we can reuse when we do decide to repair the transformers. The first item that is typically reused in a remanufacturing is the tank. When the tank comes in, typically it comes in, we would detank the active part, clean off the tank. Our team has the ability to dry blast the transformer, clean it all up, and repaint and sandblast it as well. The only other option is if we decide not to reuse the tank, the only way that it's not reusable if there's a major rip or something like that. And usually these transformers can be welded back together, but typically if there's a major explosion, then we can't reuse the tank. But most cases, we are able to reuse a tank. Also, our team in St. Louis and the other facilities as well has the ability to perform any tank modifications in case there are modifications that the customer requires before coming back to the facility. The second item typically is the core. In the past several years, from 1910 to 1970, there was a significant improvement in the core loss, the specific losses. But from 1970 on, we haven't seen really that much change in the specific losses in the core. So therefore, many times we can reuse the core of the transformer as long as there's not major failures or major problems with the core. Most of the time, I'd say about 95% of the cases, we are able to reuse the core. The core typically, if there are any problems with it, we can actually wipe down the coil, unstack it, wipe it down. If there are parts that have any burn marks or whatever, we can actually replace parts of the core. But most of the time, we can unstack the core, wipe it down with non-conductive solvent, and reuse it. The frame is also typically reused for transformers, along with the core. We'd take off the windings, remove the windings, unstack the core, and reuse the frame as well. The second portion that is typically reusable and recyclable for transformers is the superstructure and the bus and the leads. There's a lot of copper inside of this transformer, and the superstructure itself and the leads itself actually is typically reusable. You're saving a lot of money by reusing these leads. Our team can crimp or braze these leads. If there are any problems with the leads, we can replace several sections of it if needed, but the majority of the time we are able to reuse the whole superstructure or else all the leads. They can also be cleaned off using that non-conductive solvent as well. The active part in the windings. This is really what is the beef of the transformer, where the majority of the cost of the transformers. And if there is a failure in a transformer, this is the area where we see the majority of the failures. When you look at the statistics from Doble, 43% of the failures are in the active part or in the windings. The nice thing about the copper is if there is a failure and it cannot be reused, we typically recycle or we scrap the copper, sell it back to the metals company, and they can reuse that copper, and then we'll purchase it. There are oftentimes we are able to reuse parts of the windings, whether it's A, B, or C windings, but there are times when you can reuse them. One of the benefits, additional benefits to redesigning the copper is that the older transformers can be redesigned to meet today's short circuit withstands. So if you are rewinding your transformer, scrapping the copper itself, you can rebuild the transformer. You can either upgrade it or you can improve the short circuit capability of the transformers. Other items that is typically reused for transformers. You can usually reuse the bushings. If not, you can purchase new ones, and we'll recycle the bushings themselves. Arresters, CTs, coolers and radiators, the pumps, gauges, the COPS tanks. A lot of these items, such as the coolers and the pumps, can also be repaired as well. So if you decided that you don't want to replace them, we can refurbish them with our factory and reuse them. The relief devices, COPS tanks, silicone breathers, control cabinets, the conduit for the transformer, control boxes, and the oil as well. When I was asked to present this, I wanted to actually take a look at the material cost, strictly material cost of the transformer for a typical 80-100 MVA transformer at 141 kV and LTC. If you take a look strictly at the material cost, these are the items in terms of their cost percentage of the components of the transformer. As you can see, that the conductor is actually the most expensive portion. But if you take a look at just strictly on the cost, you can save a lot of money by reusing and recycling some of the parts of the transformer. This doesn't take into account, of course, the labor that goes into repairing a transformers. But if you look at it from a cost perspective, this is what it looks like when it breaks down on a typical 60, 80, 100 MVA transformer. Of course, it all depends on the design of the transformer. You get to the larger transformers, these percentages will shift a little bit differently, as well as if you go into lower MVA transformers. But this is what we have found on a specific example. These can range, like for instance, the conductor on a typical repair job, we count that as 23 to about 26%. So there is a range when you start looking at the percentage of cost for the material. Some of the additional benefits to recycling and reusing the components of the transformers. Obviously, there's the environmental benefit. When you reuse the copper, you're reducing a little bit of the carbon footprint, and you're reusing that for other uses. Kyle touched up a little bit on the biotemp, the environmentally friendly fluid. There's also improvements in performances. When you're repairing a transformer or recycling some of the components, oftentimes, like I mentioned earlier, when you repair and reuse, redesign the windings, you can improve the short circuits. If you repair the cooling equipment or upgrade the cooling equipment, you can increase the cooling efficiency of the transformers. Maintenance and training. When you repair a transformer, you're able to get back the exact same transformer in terms of footprint and design. So therefore, you're reducing the maintenance the training of the maintenance personnel. They're getting the exact same units. There's economical benefits as well. You're reusing the materials. When you're getting back the exact same transformer, you're not having to modify your substation, the foundation or anything like that. You're getting the exact same unit back. So therefore, you're cutting down on the cost of having to pour any new padding or anything like that.
I'm Kyle Wattenberger. I'm with the Transformer Service and Remanufacturing Group as well with Jimmy. And my primary focus is on transformer field service. I'm located in the Nashville, Tennessee location, the service facility. So in addition to the components that Jimmy discussed, I'm going to discuss one critical component to the transformer, and that being the oil. So we'll discuss one environmentally friendly option with reusing the existing oil, in addition to an option of converting the transformer to biotemp oil. The vision here is to provide an efficient, cost-effective, safe manner to reuse the existing fluid or upgrade the fluid to an environmentally friendly fluid in a cost-effective manner to return the transformer back to in-service condition. what is reclaiming? So just to give a general idea of oil reclamation. Reclamation is we eliminate or reduce the soluble and insoluble materials that's in the fluid. So any sludge, moisture, contamination that the fluid has accepted over time and deteriorated, the cellulose as it breaks down, we can remove that material from the insulating fluid and return it back to refinery grade material. The process, we recondition the oil. As I said, we remove the oxidation that has occurred over time. In that process, we also remove the oxidation inhibitor or stability. So we have to re-add the oxidation inhibitor back to the oil after the process has been performed. Two options here: we can perform this process online energized or offline de-energized. There are benefits to the online energized process, although not every unit can be performed in an energized fashion. So each unit, we do a job hazard analysis, a risk assessment based on the customer site, the customer's location, the surrounding equipment, and then also the human safety factor. So we do that and evaluate the benefits versus the rest. The benefits are we use the natural core losses, the heat of the transformer as it's energized, to help heat the transformer, and it helps naturally flush the transformer and to process the oil through the winding as the reconditioning is taking place. The offline, we have to bring in a portable set of heaters to bring the oil temperature up to desired temperature during the filtering process in order to extract the moisture and extract the contamination out of the oil. When should reclaiming be considered? There are two critical pieces, one being the interfacial tension and secondly the acidity. So what we can do is, as we filter the oil through the reclamation process, we remove the acidity back to acceptable limits, as well as increasing the interfacial tension to refinery grade material. The technical benefits, this is primarily towards oil exchange if we drain and replace with brand new oil, or versus the reclamation process. The negative side of just draining and exchanging and replacing is you leave 5 to 10% of the oil within the insulation system, the windings, and in the bottom of the tank that you cannot remove. So over time, I have a chart that shows over time you have a leaching effect of that high acidity content oil that leaches back into the new transformer oil, and you see an increase in acidity in the new oil in the first 6 to 12 months. The reclaiming process, as I said, allows you to flush the cellulose, the insulation system, the residual contamination, the sludge that has settled to the bottom of the tank. It allows you to flush that out of the transformer when you perform the reclamation process. That's a key benefit. And in doing that, you also extend the insulation life and the insulation system of the transformer. There is an overall cost savings if you compare the transportation, the disposal, the logistics, and the downtime would be considered as well if you would be comparing exchange of oil versus online reclamation. So you have the switching time, the de-energized time, the loss of revenue that you could also consider into that total cost calculation. And as I said, you restore the oil back to its original parameters. Again, we do a comparison based on the current oil quality in order to us to provide a guaranteed limits on what we can guarantee returning those oil parameters to. Environmental benefits includes the disposal. We reduce the disposal of the old oil and refining of the new oil as a limited resource. You avoid the transportation for both the disposal, the refining, and the delivery of the new product. and you eliminate the disposal, complete disposal, however it would be disposed of, if it's incinerated or sold to as a byproduct. And for this process, you produce very little waste, as referred to the old or traditional fuller's earth, where you'd have to you purchase of a clay fuller's earth, you get 1 or 2 processes out of that, and then you have to dispose of it in a landfill. This process you can reuse 300 to 500 times what you can the traditional fuller's earth material. This is an actual project that I was involved in. On your left would be the start of the oil. It's a class 4 collar oil, and then after, I believe, 12 total passes of total volume, you can see the incremental collar change from start to finish, from left to right. This is a presentation of a case study on replacement of new oil versus reclamation of existing oil. So if you refer to this here, you can see the customer decided to do an oil change, much like you would do in your car. You do a drain and you refill with new oil. You can see the acidity here represented on the left of the chart looked very good after the first and second month of the oil change. Starting the third and fourth month up to the year, you can see the increase in acidity or neutralization numbers in the oil. Represented here in blue with the circles, you can see the reclamation, the ABB reclamation process, the consistency over an 8-year period for acidity and neutralization. You can see you have a slight effect here of leaching up to the 0.05 acidity, but not near the impact of the oil exchange, as I was mentioning, with the leaching effect. What we do in this case is we ask our customers to either provide back samples for these incremental periods, or we'll go to site as part of the project and we'll pull the samples and send them to the lab so we can see this over time, the effect over time. This again is a similar scenario, but this in fact is the same transformer where the customer wanted to perform an oil change, and you can see the same leaching effect. In 1992 is when the exchange took place. The original oil was disposed of, new oil was exchanged and vacuum filled at this point, and then in 1998 the customer decided to do an oil reclamation to improve the acidity and the IFT, and you can see again the acidity is represented, or neutralization, on the left column, and then time on the bottom column. And as you can see, the reclamation process dropped, increased, and then stabilized over time. This is an average of 10 transformers where the acidity started at 0.1, between 0.1 and 0.2. And then, like I said, it's an average, so it's a similar chart with neutralization represented on the left and years represented, or time represented, on the bottom. So again, you can see the representation. I've got a couple slides that shows the increased level of acidity or neutralization to identify that we can bring the acidity number down to near 0.01, and then it stabilizes over time. Again, this is an average of 10 transformer. The red line here in each of the slides representing factory grade or refinery grade oil. So as you can see, over time, after the first month, it was well below the normal acidity acceptable level, and then it increased slightly above the normal, but well within the acceptable limits. Again, the oil started at 0.3, between 0.3 and 0.5. It represents very same result. Any questions regarding the process for oil reclamation? Move into a second option, and that's an ABB Biotem product. There's two options. We can do a retrofill in the field on the existing equipment, or if retrofill is considered as an option during a remanufacturing of your transformer when you bring it in the factory, both are options. The biotemp retrofill option in the field allows us to come in, remove the existing oil, perform some flushing, and backfill with the biotemp fluid. Another key option is if that is intended when the unit is going to the factory, or if there's interest, we then can look at the design parameters, the thermal parameters, the cooling parameters of your transformer, and redesign that transformer for a biotemp fluid to ensure that we meet or exceed the nameplate or design value ratings of that transformer. And this just represents an oil refinery and a sunflower field, as the biotemp, the basis of the biotemp fluid is a sunflower-based product. Candidates for biotemp: dense urban areas, indoor transformers that have high fire risk or high risk of failure that would create a catastrophic failure or a fire. Some stations with space constraints where they're around or in proximity to critical transformers, such as GSUs, or in a plant facility, as I said, inside of a building for site power or such. And key benefits are the environmentally friendly. If you do have a failure, if you do have a leak over time, you have environmentally friendly product that you can use. It's improved safety. You reduce the risk of fire. I'll go over that in the next slide as well. And you increase the equipment life, insulation life. The natural ester-based product here, as you see, has the FM and the UL ratings. It does meet the U.S. National Electrical Code, the FM and the UL, as I said, and it is verified by the U.S. Environmental Protection Agency. Also, back to the fire safety, it is classified as a K2 fire hazard. It does pass the K2 fire hazard class test, and it is specified by the industry standards. We appreciate everyone's attendance.